Hello, my name is Charles, and I'm here for Team 3. Our product is the Bellhop bike alarm, and this is design phase 3. First, I will go and review some of the steps we took in design phases 1 and 2. Then I will go on to intellectual property and how it affected our project. I will look at our design, the FMEA, our bill of materials and CAD, and our final prototype. Finally, I will go on to our future prospects for improvement of our device in future versions. Okay, so first off, what was our mission statement? Our mission statement was to create a physical product in the bike security category that we can design and launch to the market within 8 weeks in agreement with all the design constraints imposed by VTEPs. Team 3 created a customer profile based on feedback from real students at Virginia Tech on a survey we sent out. The customer profile we created was of a person with an active outdoor lifestyle who uses a bike to get to and from campus and possibly between classes on campus. The person should want a quality product that will ensure the security of their investment in the bike. Our device is therefore required to be an effective theft deterrent. It should be affordable for a college student. It shouldn't have a price considerable next to the bike itself. And it should be safe for the user. It should not have sharp edges or shock the user. Team 3 boiled the Bellhop device down into 4 sub-functions, those being detection of possible theft, the controller to take this input and feed it into the next sub-function of alarm sounding, and finally it needs to have some form of weather protection so it doesn't just stop working if it gets rained on. The team researched different components that could fulfill these sub-functions and created several combinations that could provide a solution. We put these solutions on a poster and used the gallery method to get feedback on possible improvements and possible assembling blocks for each solution. After qualitative comparison of each of our solutions, our team decided that the best solution would involve an accelerometer, a provided Arduino, an electronic speaker, and all these items would be contained within a 3D printed plastic case. So moving forward, we wanted to make sure that our device would not be a close imitation of another product in a way that would infringe on patents. And we also wanted to look at previous products that we might be able to gain insight from. For example, we looked at a 1972 patent for a bike alarm which used a padlock to restrict the movement of the lever that turned the device on and off. We also looked at a patent for a very advanced mobile device alarm, which, like our device, included an accelerometer to detect possible theft, but it was more advanced than just sounding off an alarm. It also had a GPS tracking device and could transmit its location to authorities at a fire or police station to alert them to the location of the device during an ongoing theft. Next, we did our failure mode effect analysis. We exchanged our design mockups with another team at VTEPs, Team 10. Suggestions were made to reduce the size of the device. The size is limited by the Arduino, but extra space was to be kept to a minimum. In the software, there was concern raised over the possibility of the sensitivity of the device not being right, that it could possibly be too sensitive and be set off by a gust of wind, or it might be too damped out and not detect somebody moving it. For this reason, we put a variable in our software so that we could fine-tune how sensitive the device was to changes of acceleration. And there was some concern raised over the possibility of the device being miswired. Therefore, we decided that in the final design, wiring was to be kept to a minimum to reduce possibilities of the device being miswired. So here is our bill of materials. Most of the components of our device were either already provided or could be manufactured for free for us as students. For example, the plastic case was 3D printed at the library here at Virginia Tech, which provides 3D printing for students free of charge. The two components that cost us money were the alarm and the accelerometer, the cost of which totaled up to $12, so well within our budget of $20 per person. So this is our prototype, taken out of the plastic shell, and also the battery is not included. The circuit includes the accelerometer, Arduino, and speaker. The Arduino periodically reads values from the accelerometer to determine changes of acceleration. If the changes exceed a certain threshold, the Arduino will set off the alarm, and the alarm will remain active until a certain time has passed since the device has stopped moving. Looking forward, we have made considerations for possible improvements to our device in future versions. Among those are GPS tracking, so that the user can be alerted to the location of the device if the alarm starts going off. We have also considered battery level monitoring. So currently our device simply just takes power from the battery and has no knowledge of how much power is remaining in the battery. So we have to provide the user with a suggested battery changing interval time to prevent the battery from going dead. With battery level monitoring, the battery could be kept in longer without risking discharge. We can make the alarm louder by increasing the battery voltage. And we could also use app-based arming and disarming of the device, so the user does not actually have to use a key to open up the device and turn it off. Finally, a bit of a more fun suggestion was to make the speaker digital and have a memory so that a certain sound file could be played when the alarm goes off. For example, somebody might for fun say, "Hey, stop stealing my bike!" In conclusion, Team 3 was tasked with identifying customer needs, designing a marketable product, evaluating the economic efficiency of said product, cross-checking against existing patents to make sure we did not infringe on intellectual property, and manufacturing a working prototype. Team 3 has accomplished all these tasks in record-breaking time. Groundwork has been placed for developing the project further and has been laid out should production be approved. Conclusion of the design project will lead to substantial profit for VTEX Incorporated. Team 3 would like to thank the company for the resources and support it provided.